Welcome. I am Chris, the president of the Westcat Group, and we're here today to talk about, in specific, topology and winds in regards to lightning-caused forest fires. Here with me, this is Kyle.
Hey guys, I'm a volunteer for Westcats, and today I'm hoping Chris can help explain to both you guys and myself how NRAY, the anomaly, NRAY 711, works, and the O-axis.
Yeah, so we're here, actually, this is the American fire, happened in 2013. And to start, we're going to look off in the distance in front of us. We have a northeast, a north, and a northwest wall here. What they do is they create this ridge line, so the circular ridge line. That way, when winds come through, they hit this ridge and they accelerate. So we have these negatively charged winds that come from the west, these positively charged winds that come from the south, and it's those two charged winds coming together that we get the anomaly named by the Westcat Group, NRAY 711. This is research that has been done for 7 years now, and we have confirmed that it is a huge process in creating an environment for a lightning strike. Now with that, when these winds come together and they hit this ridge line, they accelerate. It's the circular motion of the ridge that causes it to accelerate. Okay. And now they're starting a circular...
making this.
Yes,
okay.
exactly. And up here we have this pressure system, a low pressure system, applying resistance from the top, keeping these guys in, and this ridge line also applying resistance here. So with the circular motion, now we have these clouds that are coming from the west, and they carry charged particles also. And the charged particles we're getting from the earth start to react with this magnetic field that we're getting. This is the induction process, we call it. This is the induction of a lightning strike. It's the creation of the magnetic field from these heightened charges forming this circular motion right here. Okay. Now what else happens is most of the time there's usually a ridge line that sticks out, a little bit of a ridge that sticks out within this circular range here, and that applies a third point of resistance. So that when these charges accelerate, they hit this ridge and they almost chop up.
Basically causing like a friction or maybe a static friction?
Yeah, exactly. Okay. So when these charges get chopped and you get the static motion, it's perfect for these charges to come together. That's what really creates a spark, as you could say. Okay. It creates a spark, and these charges accelerate. There's a point of acceleration, and they create what we see a lightning strike. And this lightning is going to hit a tree that is carrying the most heightened opposite charge with it. That's the tree that's going to get struck. Okay,
now I understand we have a huge body of water next to us, the American River. Does that play into this factor at all?
Right, it does, and it does play an important factor into everything, the O-axis and NRAY 711. So these rivers, or bodies of water, rivers, lakes, reservoirs, aquifers,
any large
underground
bodies
aquifers, yes, what they do is they bring heightened elements of charges, so that when these winds come through, they pick up all those extra charges, and it just creates more of a severe case of charge reaction, because there's elevated levels of charges.
Amounts of energy in one area.
Yeah, exactly. So now that we have all of these coming together from all these different sides, this is the O-axis. It's a circumference way of things coming together to things. So now it's not just planes that we're talking about. It's things coming together from all directions.
Okay.
Yeah, exactly. And I'm also going to throw out something here that we can also talk about in regards to fires and topology and winds, is that this isn't only useful when you have lightning-caused forest fires. When you have fires caused by humans as well, the topology plays a huge part in the way that these fires accelerate and the way these fires advance and are created. Okay. So the ridgeline and the winds and these bodies of water still feed these fires. So even though these fires are created, you can tell by looking at the topology how this wind or how these fires are going to accelerate and maybe the direction they're going to head to and which point of resistance they're going to find. Okay. So you can actually plan your attack and plan your defense around how the topology is formed, because that'll play a huge role in which way you can help to resist and prevent this fire from spreading even further.
More of like a 21st century tactical way of attacking these fires.
Exactly. It's a new strategy, new tactics. It could help prevent situations in which
Oh yeah.
which we're in the wrong spots at the wrong time.
Right. Save lives.